Hello everyone! In this video lesson, we will discuss about sampling distribution of the sample mean. Sampling distribution of the sample mean is a probability distribution of all possible sample means of a given sample size. The sampling distribution of the sample mean can be thought of as for a sample of size n. The sample mean will behave according to this distribution. Any random draw from that sampling distribution will be interpreted as the mean of a sample of n observations from the original population. Consider a population consisting of these four values. The mean of this value is 5.25. The population standard deviation is 2.165. Now, suppose we select all possible samples of size 2 with replacement from this population and compute the sample mean x bar for each sample. This is now a distribution of sample means. We find that the mean of these sample means is 5.25. which is the same as the mean of the original population, and the population standard deviation of the sample means 1.531, which is equal to the population standard deviation divided by the square root of the sample size used, which is 2, that is sigma over square root n. In a sense, the mean of the sampling means will always equal the population mean, and the standard deviation of the sample means, also called standard error of the mean, will equal the population standard deviation divided by the square root of n. Now, we have the central limit theorem, which basically says as the sample size increases, the sampling distribution of the sample means will approach normal distribution. That is, if the population is normal, then the distribution of sample means will also be normal. And if the population is not normal, the distribution of sample means become approximately normal when n is large. And by large, we often say when n is at least 30. Now, recall that an individual score x in a normal population is standardized using x minus mu over sigma. To standardize the mean of a sample of size n, we replace the x by x bar and change the standard deviation to the standard error of the mean. Let's look at an example. Given a normal population with a mean of 63 and a standard deviation of 12, find the probability that a random sample of size 16 has a mean greater than 61.5. We have the sample here, with sample size provided, and we are finding the probability for a sample mean and not for an individual score. So, we can apply the Z formula for sampling distribution of the mean. The standard error is 12 divided by root 16, which gives 3, and the Z score is 61.5 minus 63 divided by 3, which gives negative 0.5. Looking that up in the less than cumulative normal table, we have a less than area of 0.358, so the greater than area is minus 0.358, which gives 0.6915. That is the probability that the sample mean is greater than 61.5 is 0.6915. Next, what is the use of sampling distribution in real life? So, sampling distribution are important for inferential statistics. In practice, one will collect sample data, and from this data, estimate parameters of the population distribution. Thus, knowledge of the sampling distribution can be very useful in making inferences about the overall population. And then, why is distribution important in statistics? Sampling distribution are important for statistics because we need to collect the sample and estimate the parameters of the population distribution. Hence, distribution is necessary to make inferences about the overall population. Now that we have discovered the possibility of a sampling error when sample results are used to estimate a population parameter, how can we make an accurate prediction about the possible success of a newly developed toothpaste or other product based only on sample results? How can the quality assurance department in a mass production firm release a shipment of microchips based only on a sample of 10 chips? How can the CNA or USA Today or ABC News or Washington Post polling organizations make an accurate prediction about a presidential race based on a sample of 1,200 registered voters out of a voting population of nearly 19 million? To answer this question, we first develop a sampling distribution of the sample mean. The sample means in the previous example varied from one sample to the next. The mean of the first sample of 5 days was 3.80 rooms, and the second sample was 3.40 rooms. The population mean was 3.13 rooms. If we organize the means of all possible samples of 5 days into a probability distribution, the result is called the sampling distribution of the sample mean. And here, another example. Tortoise industry has 7 production employees. Consider the population. The hourly earnings of each employee are given in table 8.2. And the question is, the first, what is the population mean? And the second, what is the sampling distribution of the sample mean for sample of size 2? And the third, what is the mean of the sampling distribution? And the fourth, what observation can be made about the population and the sampling distribution? So let's find the solution. Question number 1. What is the population mean? We identify the population mean with Greek letter mu. Our policy states in chapters 1, 3, and 4 is to identify the population parameters with Greek letters, and the population mean is $7.71 found by mu equals sigma x divided by n equals 7 plus 7 plus 8 plus 8 plus 7 plus 8 plus $9 divided by 7 equals $7.71. And the question number 2, what is the sampling distribution of the sample mean for sample of size 2? To arrive the sampling distribution of the sample mean, we need to select all possible sample of 2 without replacement from the population. Then compute the mean of each sample. There are 21 possible samples found by using formula 5 to 10, where n equals 7 is the number of items in the population and n equals 2 is the number of items in the sample. The 21 sample means from all possible samples of 2 that can be drawn from the population are shown in table 8.3. These 21 sample means are used to construct a probability distribution. This is the sampling distribution of the sample mean, and it is summarized in table 8.4. Question number 3. What is the mean of the sampling distribution? So, The mean of the sampling distribution of the sample mean is obtained by summing the various sample means and dividing the sum by the numbers of samples. The mean of all the samples means is usually written mu x bar, and the mu reminds us that it is a population value because we have considered all possible samples. The subscript indicates that it is the sampling distribution of the sample mean. And the last question is, what observation can be made about the population and the sampling distribution? Refer to chart 8.1, which showed both the population distribution and the distribution of the sample mean. These observations can be made. A. The mean of the distribution of the sample mean, $7.71, is equal to the mean of the population, which is mu equals mu x bar. The spread in the distribution of the sample mean is less than the spread in the population values. The sample mean range from $7 to $8.50, while the population values vary from $7 up to $9. Notice, as we increase the size of the sample, the spread of the distribution of the sample mean becomes smaller. And the shape of the sampling distribution of the sample mean and the shape of the frequency distribution of the population values are different. The distribution of the sample mean tends to be more bell-shaped and to approximate the normal probability distribution. In summary, we took all possible random samples from a population and for each sample calculated a sample statistic, the mean amount earned. This example illustrates important relationships between the population distribution and the sampling distribution of the sample mean. The mean of the sample means is exactly equal to the population mean, and the dispersion of the sampling distribution of sample means is narrower than the population distribution, and the sampling distribution of sample means tends to become bell-shaped and to approximate the normal probability distribution. So that's all discussed about sampling distribution of the sample mean. Thank you. Goodbye.